So today we're going to finish up the notes on section 2. We're just going to graph a few more examples of rational functions. And again, remember, rational functions are just another name, another way to say a fraction. So what we're going to do here first is I could see if I could go ahead and check for my horizontal asymptote first. So remember, to find the horizontal asymptote, we look at the degrees. So the degree of the numerator is a 2. The degree of the denominator is a 1. So here, my numerator is bigger. So in the answer, you would put that there is no horizontal asymptote. Remember that when the degree of the numerator is 1 larger, this is going to have a slant asymptote. To find, and we didn't do this yet, to find the slant asymptote, we need to do long division. So I'm going to divide the numerator by the denominator. So let me go ahead and do a long division problem to get my slant asymptotes equation. Okay, so for the slant asymptote, I'm taking the numerator of the fraction, the x squared minus x, and I'm going to divide it by the denominator. So I'm using long division here. Remember when we did it, we were supposed to like hold the places and have placeholders for every single term. I'm just going to put the plus 0 in there, so just when I go to subtract, it'll make sense. So again, when you're doing long division, we're trying to figure out what are we going to multiply x by to make it x squared. So I'm going to multiply it by an x. Remember, you're going to distribute the x to the x to the 1. And then now when we go to subtract, we're going to flip all the signs to opposite. So I'm going to make this negative and this negative. Now I'm going to go ahead and subtract. That cancels. And then when I subtract here, I end up getting negative x plus negative x is negative 2x. I'm going to bring down the 0. And now I need to figure out what do I need to multiply x by to make it negative 2x. And I need to multiply it by negative 2. I'm going to multiply. I'm going to flip the signs to opposite. This is gone. And now 0 plus 2 is 2. Now, when I'm doing the long division to get my slant asymptote equation, I don't care about the remainder. All I'm going to keep is what I got when I divided on the top. So my slant asymptote equation is y equals x minus 2. This is a linear equation. I'm going to be graphing this on my graph. Next, I'm going to find my vertical asymptote. So to find the vertical asymptote, I need to simplify my fraction first. So in order to simplify my g of x function, I can factor out the variable x from the numerator. Now, that's really not going to help me cancel anything. It's still going to leave my fraction the same, but when I go to find my x-intercept, it would help me. So I'll go ahead and, to find my x-intercept, I'm going to use the numerator. So I'm going to do g of x. I'm going to factor out a GCF of x, and then I'm left with x minus 1. The denominator is still the same, x plus 1. Now, by factoring that GCF of x out, it doesn't give me anything to cancel. So, but I did need to make sure that nothing would simplify to find my vertical. Now for your vertical asymptote, remember you set the denominator equal to 0. So I'm going to set x plus 1 equal to 0, subtract 1, and my vertical asymptote is located at x equals negative 1. The next thing I'm going to do now is find my x and y intercepts. So in order to find an x-intercept, remember we're going to set y equal to 0. And again, now, in order to find my x-intercepts, I'm setting y equal to 0. Remember, this g of x that was here, this is just a fancy way of saying y equals. So my equation that I'm plugging a 0 in for is y equals x squared minus x over x. So I could put in the 0 for the y. Now remember, I had already factored that numerator into x times x minus 1 over x. Now when we go to solve this, again, remember the x-intercepts, really all we have to do is set the numerator equal to 0, because once I try to get the x out of the bottom, this cancels. So now I'm left with 0 equals x times x minus 1. Since it's already factored, you're going to set each factor equal to 0. And then I'll take the next one, the x minus 1, set it equal to 0. And I have two x-intercepts. I have an x-intercept at the order pair 0, 0, and the purple one, 1, 0. These are my x-intercepts. Now I need to find a y-intercept. So to find the y-intercept, I'm setting x equal to 0. So once I do that, I take my y equals x squared minus x over x. And then once I plug in all these x's, oh, this is an x plus 1. Let me fix this. So this is x plus 1 here, but again, it's gone. It doesn't matter. But again, let's go ahead and plug in zeros for all these x's. So y equals, so every place I see a x, I'm going to put in a 0. Once I simplify this down, I get 0 over 1. 0 divided by anything is 0. So my y-intercept is the order pair 0, 0. So I actually have an x and a y-intercept that's the same order pair. So this is my y-intercept. And now remember, yesterday I told you that you can use your calculator to get additional points. Now, again, if you did not have a calculator, you can, and let's say this is an SAT question and they don't, it's in the non-calculator part, then you would do a table of values. So you would take your function, which was the x squared minus x over x plus 1, and then plug in some numbers. Now, I need to pick numbers that are on either side of my vertical asymptote. So let me go ahead and put these asymptotes in here first, and these ordered pairs. And then that way I'll know what x values to pick. So I had no horizontal asymptote. I've got this slant asymptote that I've got to graph. So I'm going to start at my y-intercept, which is -2. My slope here is 1. So I'm going to rise 1, run 1. And I can repeat this. So this is my slant asymptote. This is the y equals x minus 2. This is the slant asymptote. And then I also had a vertical asymptote at x equals -1. No horizontal here. So now I'm going to pick values of x to plug into the function to the left of the blue line and to the right of the blue line. And the degree of the numerator is larger than the degree of the denominator, which was what we did here. That's when you have no horizontal. Now, so only if there's no horizontal, the only time you have a slant asymptote is when the degree of the numerator is 1 bigger. If they're further apart than that, then there is no slant. So you don't have to have a slant when there's no horizontal. The only time you have a slant is when the degree of the numerator is 1 larger than the denominator. So here what we're going to do is I'm going to pick a number for x that is to the left of my blue line. Actually, I'm going to plug in 2. So again, here's my little chart here. I'm going to plug in -2, and I'm also going to plug in -4. So when I plug in -2 and square it, minus -2 over -2 plus 1, this gives me 4 plus 4, no, 4 plus 2, sorry, over -1, and then this is gonna, and this gives me 6 over -1, which is -6, so I can graph the order pair -2, -6. I'm also going to plug in -4. So -4 squared minus -4, -4 plus 1, 16 plus 4 over -3. This gives me 20 over -3. Since I'm graphing a point, I'm going to make it a mixed number. So -6 and 2/3. So -4 and -6 and 2/3. So let me go ahead and get those 2 points on my graph. So -2, -6, right here. And then -4, 1, 2, 3, 4. And then 6 and 2/3 is going to be a little bit lower. And then you're going to make your little boomerang shape in here. And that would be that part of it. And now I need to get the other piece of the graph. So I also had my intercepts. Let me plug those. So I had 0, 0. And I had also, the other intercept was 1, 0. So I already have those 2 points. Let me get another one. I'm going to plug in +2. 2 squared minus 2, 2 plus 1, 4 minus 2 over 3, 2 over 3. So this order pair is 2, 2/3. So again, it's kind of hard to see because my graph goes by just ones, but I could put 2 and then 2/3 like right there. So my graph is actually going to come like this. Now, again, on the quiz next week, you don't have to do this. You're going to use your calculator. So, for example, I'm going to go ahead and key in the function into my calculator. Now, when I key it into my calculator, I'm going to hit the y equals button up at the top. Remember, you need to put parentheses around the numerator. So I'm going to put parentheses and then x squared minus x divided by x plus 1. And then I'm going to hit graph. You'll see the same graph I just made. And then you're also going to see the table of values when I show you that. So let me go ahead and get this keyed in. And again, after I do these examples, if you need help with your calculator, I can help you with that. Okay, so let me show you what it looks like. That is the domain, all real numbers except when x equals -1. That was where our vertical asymptote was located. And then in interval notation, again, it was -infinity to -1 union with -1 to infinity. Let's try another one with another slant asymptote. So again, for this horizontal, again, I look at the degrees. The top one has a degree of 2. The denominator has a degree of 1. Notice, since the top is bigger, there is no horizontal asymptote. However, the top is 1 larger, so only when the top is 1 larger, then we have a slant. And we find the slant by doing long division. So I'm going to take the numerator, I'm going to divide it by the denominator. Again, what am I going to multiply x by to make it x squared? I'm going to multiply it by an x. I'm going to distribute the x to the x to the -1. I change the signs to opposite. I now can add my column here, and they actually both cancel. And then once I bring down, this is 0, this is 0. And once I bring down the -2, that's just my remainder. So my slant equation is just y equals x. I'm only using this. For the vertical, remember you need to simplify the fraction first. So I need to see if anything will simplify. So if I factor the numerator will factor into x minus 2, x plus 1 over x minus 1. Nothing cancels. So for the vertical asymptote, all I need to do is take the denominator and set it equal to 0. So x minus 1 equals 0, add 1, and my vertical asymptote is located at x equals 1. Let me go ahead and put both of these asymptotes on my graph. So I got a vertical right here at +1. Let me do it in blue. And then for my slant asymptote, my y-intercept, when it's y equals x, there's no y-intercept at 0. So I'm going to start at 0, 0. Again, my slope is 1. So I'm going to rise 1, run 1. So here is my slant asymptote. And now let me go back and get my x and my y intercepts. And we find those by plugging in zeros. So to get the x-intercept, I'm going to set y equal to 0. Now remember, the x-intercepts, all we really need to do here is set the numerator equal to 0. But I'll show you the math behind it. So it's y equals, my function is this, and I'm going to take the factored one. You don't have to, but it'll make it a little bit easier. So I'm going to take out y, this y right here, I'm going to erase it, and I'm going to put a 0 there. I want to get rid of the x minus 1 out of the bottom. So I'm going to multiply both sides by x minus 1. Cancels from there. And again, the whole purpose of just setting the numerator equal to 0, anything times 0 here, when I move that denominator, this just becomes 0. So it's 0 equals x minus 2 times x plus 1. What was nice is it was already factored. So now I just have to set each factor equal to 0. And I have an x-intercept. An x-intercept located at 2, 0. And then I got another one located at -1, 0. These are my two x-intercepts. For my y-intercept, I'm setting x equal to 0. So again, I could either take the simplified one or I can take the factored one. doesn't really matter. If I go back to the original one, that might be easier. Plug it in here. So every place that I see x, I'm going to put in a 0 there. So I get y equals 0 squared minus 0 minus 2. 0 minus 1 gives you negative 2 over negative 1. Negative divided by a negative, and this becomes positive 2. So my y-intercept is located at the order pair 0, 2. So let me go ahead and add these intercepts, and then I'll just get the additional points from my calculator. So let me put an order pair on 2, 0. So right here. And then I have negative 1, 0. Those are my two x-intercepts. And then my y-intercept was the order pair 0, 2 up here. Now, you can already see that over here on this side, you can connect these two and just use the asymptotes as the guide. And then over here, this is going to be the location of the other boomerang shape. And again, you can get the additional order pairs from your calculator. Some other order pairs, if you pulled it off of your calculator, negative 2 and negative 1.3 repeating. Another one could have been 2, 0, which we already had, and then 3, 2. So these could be some additional order pairs that you could get to create your graph. Once we've simplified this, nothing canceled, so there was no hole in this graph. The domain for this one is everything except the asymptote, that blue line. So the domain here, again, all real numbers, except when x equals 1. And that's where our asymptote is. In interval notation, it would be negative infinity up to 1, union from 1 to infinity. And then one more example. Again, they're not bad problems, they're just a little tedious work here. So again, nothing's going to simplify here. So I don't have to worry about trying to factor anything. I'm going to do my horizontal. Degree of the top is a 2. Degree of the bottom is a 1. Again, the top is bigger, so no horizontal asymptote. Again, because the top is 1 bigger, we've got the slant. So again, I need to do the long division. So 3x squared. Remember when you do long division, you got to put in a placeholder. So there was no x term, so I'm going to put a 0x, then the 1, and then divided by the denominator. What are we going to multiply x by to make it 3x squared? I'm going to multiply it by a 3x. 3x squared. Once I subtract, and then I'll bring down. Since there's nothing to multiply x by to make it a 0x, this is just what I need. I don't worry about the remainder, so I just have my slant equation as y equals 3x. So I could go ahead and graph that right now. This is in y equals mx plus b. I start at 0, 0, 0. I rise 3, run 1. And then I could connect these points and make my slant asymptote. So that's the slant. Let me find my vertical asymptote. So remember, for the vertical asymptote, we set the denominator equal to 0. So it's just x equals 0. So my vertical asymptote is the y-axis here. And now I can find an x-intercept. By setting y equal to 0. Again, all I need to do is the numerator. So it's 3x squared plus 1 equals 0. When I subtract, I get 3x squared equals negative 1. Divide by 3. X squared equals negative 1/3. As soon as I start to square root a negative number, I know I'm going to get an I out of this. I do not want any imaginary, so no imaginary solutions. I'm not graphing imaginary numbers, so I would say no x-intercepts. For the y-intercept, remember you're going to set x equal to 0. So y equals 3x squared plus 1 over x. Y equals 3 times 0 squared plus 1 over 0. I get 0 plus 1 over 0. 1 over 0. I can't have a 0 on the bottom. This is undefined. So no y-intercepts either. So then what I would do now is I would key this function in my calculator and I would get additional points from it. So let me go ahead and do that one and I'll tell you the additional points and show you what it looks like. So y equals, again, put parentheses around it when you do this. All right, so I'll show you what I keyed in, and then I'm going to graph it. The boomerang shapes on there. Again, you don't have to plot a whole bunch of little order pairs right in there. So this was the last example. Again, remember, use Calc Chat to check your homework. And then if you have any questions when you come in tomorrow, I will answer them. Tomorrow I will be introducing Chapter 5.